Hi students, in this class we will learn question numbers 6 to 10 from the exercise 10C of the chapter Electromagnetism. Please watch the video on electromagnetic induction before answering these questions. The link is provided in the description box. Question number 1. Describe briefly one way of producing an induced EMF. B part, state one factor that determines the magnitude of the induced EMF in part A above. C part of the question, what factor determines the direction of the induced EMF in part A above? We know to produce an induced EMF, we need a change in magnetic flux. As you can see from this diagram, this coil is moved towards the bar magnet. This is the north polarity of the magnet, and the magnetic field lines at the north pole is shown in the diagram. This coil is moved towards this magnetic field lines. When it comes closer to the magnetic field lines, the flux linked with the coil increases. When there is a change in the magnetic flux, an induced current is produced. When an induced current is produced, this can be detected using the instrument or device called galvanometer. This galvanometer is connected to the coil so that this circuit is complete. This is a closed circuit. Current flow can be detected using the galvanometer. Always remember, only when there is a change in magnetic flux, an induced current is produced. The answer for this question is when there is a relative motion between the coil and the magnet, magnetic flux linked with the coil changes. As shown in the diagram, in figure B, the coil is moved towards the north pole of the magnet. So the magnetic flux through the coil increases. Similarly, if the coil is moved away from the north pole of the magnetic flux through the coil decreases. Due to the change in the magnetic flux linked with the coil, an electromotive force is induced in the coil. The induced electromotive force causes a current to flow in the coil if the circuit of coil is closed. Answer for B part is the magnitude of induced EMF depends on the rate of change of magnetic flux linked with each turn. Answer for C part, the direction of the induced EMF depends on whether there is an increase or decrease in the magnetic flux. It can be determined by any of the following two rules: Fleming's right hand rule and Lenz's law. Always remember in this question, only when there is a change, either increase or decrease, only when there is a change in the magnetic flux, an induced current is produced. And to determine the direction of this induced EMF or current, we use two rules. One is Fleming's right hand rule and the other is Lenz's law. Question number 2. Complete the following sentence. The current is induced in a closed circuit only if there is. You have to fill in this blank. How will you answer this question? Answer for this question is the current is induced in a closed circuit only if there is a change in the number of magnetic field lines linked with the circuit. Question number 3. In which of the following cases EMF is induced? Part 1. A current is started in a wire held near a loop of wire. Second choice. The current is switched off in a wire held near a loop of wire. Third choice, magnet is moved through a loop of wire. Fourth choice, a loop of wire is held near a magnet. Four choices are given, and in which of the following cases an EMF is induced? We know if EMF is to be induced, there should be a change in the magnetic flux. Among the choices given, the first choice, the answer is yes, EMF is induced because when current is started in a wire held near a loop of wire, magnetic field varies, due to which EMF is induced. When current is started means current is rising, it is increasing. When it is increasing, there is a change. Whenever there is a change, an EMF is induced. Therefore, in the first case, the answer is yes. In the second case, or the second choice, also the answer is yes. EMF is induced because when current is switched off means from initial value, it is decreasing. It is switched off in a wire held near a loop of wire, the current stops and the magnetic field again varies, and hence EMF is induced, because in this case when the current is switched off, the value is decreasing. If it is increasing or decreasing, there is a change. Whenever there is a change, an EMF is induced. Therefore, in the second case also, the answer is yes. For the third case, in that case also, the answer is yes, EMF is induced, because in that case there is a relative motion between the magnet and the loop of wire. If there is a motion between the magnet and the loop of wire, the magnetic flux will change. Therefore, EMF is induced. What about the fourth case? In the fourth case, no EMF is not induced. Why? Because it is stationary. When a loop of wire is held near a magnet, there is no change in the magnetic field, hence EMF is not induced. It is held stationary, it is not moving. That means there is no change in the magnetic flux. Question number 4. A conductor is moved in a varying magnetic field. Name the law which determines the direction of current induced in the conductor. We know when a conductor is moved in a varying magnetic field, an induced current is produced. In this question, you have to name the law which determines the direction of the induced current. The answer is Fleming's right hand rule. Fleming's right hand rule. This gives the direction of the induced current. When a conductor is moved in a varying magnetic field, Fleming's right hand rule determines the direction of current induced in the conductor. Question number 5. State Fleming's right hand rule. How will you state Fleming's right hand rule? From the name itself, it is clear that you should take your right hand. Hold your right hand such that your thumb, the middle finger and the forefinger of your right hand mutually perpendicular to each other. As shown in this diagram, this is the thumb and this is the forefinger or the first finger. This is the central finger or the middle finger or the second finger. They are mutually perpendicular to each other. You have to hold your right hand such that these three fingers are mutually perpendicular to each other. The thumb represents the motion of the direction of the conductor. You can remember in this way, thumb, T-H-U-M-B. This M stands for the motion of the direction of the conductor. The first finger, F, first finger or the forefinger, this F stands for the field, the magnetic field. If you remember in this way, you will not forget first finger or the forefinger stands for the magnetic field. Thumb represents the motion of the direction of the conductor. And this Fleming's right hand rule is used to find out the direction of the induced current. The induced current direction is represented by the middle finger or the second finger. In this way, you can easily remember the Fleming's right hand rule. If you like this video, please share with your friends. Thank you.